All right, chemical energy is an energy involved in a chemical reaction, and this energy is in chemical bond, right? Associated with the bond forming, bond breaking. In a chemical reaction, the bond is formed, the bond is break all the time, right? Then there's energy involved, and you can see in two types. We have the reaction that releases in energy, and the reaction that absorbs energy. Okay, the type that release energy we call exothermic reaction. You probably heard this word before. And the one that absorbs energy we call endothermic reaction. Okay, all right, now let's take a look here. So relative energy, so they all have potential energy, right? But if you look at the equation, so equation means the energy on the left side, the reactant, and the energy on the product have to be equal, right? So the overall, this reaction releases energy, which means that the reactant has higher potential energy than the product C, because it releases energy, right? The energy have to be equal. So higher potential energy, so low potential energy. Give you some easy numbers. So let's say if A plus B, A and B combined, the energy is 10. The energy of C is 3. The heat release is going to be 7. Okay, so obviously, totally, the reactant has higher energy 10 than the product, which is 3. All right, and all right, here's the energy diagram. You're gonna see this very, very often from now on. So I just want to show you at right here. I don't think that the textbook have a potential energy diagram at the beginning in the chapter, because it is come later. But I want you to see right here first. Okay, so show you as a relative potential energy. So A and B has higher energy than C. So right there, the energy level of A and B, and that's energy level of C. Okay, you can see that energy release right here. In chemistry, anything that has high potential energy is called unstable, and anything that has low potential energy we call stable. Okay, so unstable go to more stable product. All right, so that's exothermic reaction. Now we move on to down here to endothermic reaction. So heat is gained right here, right? So the reactant absorb heat. So totally, the reactant has lower energy than the potential energy of the product. Okay, so low potential energy, so need more energy to be equal to the product. So higher potential energy. So A and B gonna start real low, right there, and the product has higher potential energy. Okay, and in chemistry, anything that have low in energy we call stable. Anything that has high in energy we call unstable. Okay, so this reaction overall is absorb energy. We call endothermic reaction. All right. Now, an example of exothermic reaction. Many reactions are exothermic reaction, which means it releases heat. So we'll start out with the highly reactive or unstable reactant. We have hydrochloric acid, which is a strong acid. I'm sure you heard about it. Sodium hydroxide, which is a strong base. Anything strong is unstable. They store a lot of energy in there, high potential energy. And to form more stable compound like sodium chloride. Sodium chloride is super stable. You see sodium chloride everywhere you eat it. It doesn't do anything to you, right? Water is super stable. Okay, and what happened here? So hydrogen pair up with OH to form water. Chlorine pair up with sodium to form sodium chloride. Okay, and so high energy reactant to make low energy or more stable the product. And here's the reason why you should not make strong acid and strong base. You should not mix strong reagent and strong reagent, unstable and unstable together, because it's going to react violently. Now let's take a look right here. It will release a large amount of energy. Now I got a video right here. So okay, here we go. Let's take a look. So there's sodium hydroxide in the flask. Okay, that's sodium hydroxide. And then he's going to pour hydrochloric acid into it. So watch out. Woo! Little bit explosion. We got a and adding water to just calm it down. Reaction is really exothermic. All right. That's adding water into it. Can you see that? That's salt right there. That's sodium chloride salt right there. You get from sodium chloride. Oh, we got a slow-mo. release large amount of energy. Okay. All right, let's practice together here. So which item in each pair has more potential energy and which one is more stable? Well, we talk about potential energy. Potential energy depends on the reference point, all right? The reference point right now is from the ground, all right? So B is higher position, so it's higher potential energy, and of course, less stable. So which one more stable? A is more stable. Okay. All right, we got a spring at a static position and a compressed position. Okay. So which one has more potential energy? The one that is compressed, right? The one is compressed. So, and the static is more stable. Okay. So the reference point is that reference point. This one got compressed, right? So that's a distance right here. Next one, all right, we have wood and we have ash, all right? So which one has more potential energy? Well, wood has higher potential energy and ash has lower, right? And here's the reason why. If you can heat up heat up wood, like burn wood, you get ash. And if you burn ash, what do you get? You get nothing. There's no reaction, right? So totally ash is more stable than the wood. Can't do any reaction in it. Okay, so high potential energy, low potential energy, so more stable. Ash is more stable. Okay, let's moving on to the next video.